Great. Let's see how this goes. My name is Matt. I'm going to talk today about a concept called harness engineering. It's a term that's fairly new in the agentic development space that I fairly like. I will start with a few words about me. I'm going to talk a little bit about the software development process, kind of tangent and related to the engineering process. It's funny how we're talking about agentic development, so I guess there has to be some overlap. And then I'll talk about how the software development process can be executed with agents. And we're going to end with a bit of a practical example and maybe some time for questions. I'm Matt. I'm the founder of Ford, which is a consultancy business helping companies with AI and technology. I'm also the head of AI and engineering at Revoice, where we work on voice and speech technologies. Before that, I worked in a lot of different industries and places. I dabbled with the space industry, working on the European Robotic Arm at the European Space Agency. And yes, there is a real photo on the ISS. Was recently filmed there. I also worked at a space company here in Ottawa called Mission Control Space Services that has a majestic moon yard in the back where we were building rovers and driving rovers, but specifically we're building tools and platform to control lunar rovers. I also worked on a massive streaming scale platform, streaming movies that at the time had around 1 million users in Africa. So a lot of early experiences. But through all of these experiences, what really kind of was important to me, what kind of the question that resonated with me from the beginning was, how do you build great software? Yeah,
I have answered that question. So This is my idea. But first, we have to find what the problem we're trying to solve, and then develop a prototype to solve the problem. Then we create a simple implementation, and then we expand upon that implementation, and there we go, great software. And then we improve upon it.
Works in theory.
Pardon me?
It works in theory.
Very much in line with what you said. It's what you described as a process. Yeah. And basically the way how you build great software is you follow the process, follow best practices, follow the patterns that people have already established. And that is what we call engineering inherently. Over the years, the process of developing software has been materialized in what is referred to as the software development lifecycle. And there's a lot of different ways how to talk about it. And maybe Bobby will talk about it a little bit of a different way later on. But essentially, this is how I want to talk about it. You start with an idea. As the first step, you define what you want to build. You can define those requirements as a job description, but essentially there is an idea of what you want to build. The second step is design. You think about how you want to materialize the idea, how you want to structure your application, your software, how you want to you essentially architect it and plan it. Then you implement it, then you verify it, you review it, you basically make sure that it does the thing that it should do. Here, for the purpose of this presentation, I'm talking about review as a step that includes both code review and quality assurance and testing. Essentially, we want to make sure that the software is built in a way that we want to build and it does the thing that we want it to do. And then you enter maintenance, where you maintain the software, you provide bug fixes, maybe new features, etc. The more pressing question these days seems to be, how do we make AI agents build great software? Companies talk a lot about using AI agents to develop applications, some with more success, some with less. So the question on everybody's mind right now is, how do we move more of that work towards AI agents and less towards humans? And the concept of harness engineering came up from that need. Essentially, harness engineering was developed as a concept by OpenAI that established in a recent blog article. And the concept is simple. We don't want humans writing code. We want humans to be building and managing the environment in which agents write code.
Carry on.
And this is a very dynamically developing space that honestly did not exist 2 or 3 months ago. But still, a lot of companies are coming forward saying, hey, we tried this. This is our best practices. Companies like Shopify, Stripe, Cube, and a number of others have started publishing either tools or blog articles about how they are doing it. I've analyzed the space, and I think right now we have a few rules that we can clarify from all of those lessons learned, and I'm going to talk to you about these rules. Rule number 1, what works best? If you constrain the agent, don't instruct it. So agents that have less tools, less less scope, more specific instructions perform better. So the trend is that we narrow down what the agent can do and should focus on. I think it was Vercel that cut their available tooling by 80% and the agent performance increased dramatically. Second rule is that you encode taste in tooling, not in review. I'm not sure what's your experience. My first job, we spent a lot of hours discussing about code styling, discussing single quotes, double quotes. All of that can be done by linters now and should be done by linters. We don't want human time to be spent on code review and styling review of the code. And pushing this idea to the extreme, you want to build also tooling that checks your architectural principles and ensuring that the application is built in a way you want it to be built for future maintainability. The more ideology about development you can encode in tools, the better. Corrections are cheap, waiting is expensive. The faster you can get the model to produce an output, the better. At OpenAI, they claim they prize themselves that they are on average shipping, when doing harness engineering, they're shipping on average 3.5 pull requests per engineer per day, which is a dramatic speed, but it also means that those changes are smaller. You want to scope the work in a way that the agent does a little bit of work, you review it, you merge it, you move on. My sweet spot has been around 300 to 500 lines of code, and I find that those changes are big enough that the agent spends some time working on them and small enough that you can review it in a minute and continue with the work. So that's also something to keep in mind. The best multiplier you get is with parallelization, not speed. So agents can be slower if you ask them to plan every little thing, to double check every little thing, to check tests and rerun linters and tests and self-review. All of that can be inherently slower if you want to run a small change. But because you can run more agents in parallel, that's where you get the boost. So the best teams seem to be working in a way that every developer, every engineer is running 2 to 4 background sessions while working themselves on a single more complex feature. And that's where you get the multiplier. And of course, research, plan, implement, never skip the plan. This is something where kind of loops back to the first point. The more specific instructions you give the agent, the better it performs. So first you plan, you spend an agent to analyze the problem and come up with a step-by-step solution. And then you have another agent to implement that solution, and that works remarkably well. So a practical example is how I build a harness for building better code faster for one of my side projects. And now I'm taking that harness and implementing it in other projects that I'm working on. This is showing, you can imagine this as a what's the word? Sequence diagram. So you read it from the bottom down. Every column is an actor. Here I implemented this with me being the human. There's an agent, there's a Jira for storing tasks and work, and there's a Git for submitting code. And we're reading this from top to bottom. So the sequence of events goes from top to bottom. So for the idea stage, essentially human comes up with an idea of what to build. I create a task in Jira in the idea column. The agent for the design phase, it will pull that task from Jira. It will fire up a plan skill. Here it's important to note that the agent can identify that this is an idea task, so it knows what to do with it. It's an idea, so I need to plan the implementation. It will fire up the plan skill, create a plan, and write that plan to Jira. Now, the Jira ticket is moved to a plan review column. Human at some point comes over, checks it, can understand the plan, review the plan. You can make comments, you can argue with the agent for a moment, but ultimately you approve the plan and you produce an approved plan item in Jira. The agent then picks up such an approved plan item. It will execute another skill. It can identify that this ticket is now in the state of approved plan. It will then decompose that plan into tasks. It's important to mention that as a part of the plan process, the agent suggests the tasks that are supposed to be taken to execute this plan. So this step is about just decomposing it based on the plan and creating those individual tasks. As I said before, each task is scoped to 300 to 500 lines of code to make it small. And also tasks can have internal dependencies. They can depend on each other. So an agent will not pick up a task before its dependencies are cleared. Once we have tasks to work on, we can move on to the implementation. The agent will pull the task from Jira. It will move that task to in progress. It will implement it using an implement skill. And then after it's done with implementing, it will trigger a rep development skill, which will run a code review agent on that, run unit tests, run linter, everything the agent can do to verify that the code is up to spec before opening up a pull request in Git and moving the task to request review in Jira. And that's where a human comes in. In parallel, we are running CI/CD and in Git, so all of the tests, all of the lints, anything that we want to run runs on Git. In the meantime, the human can check the code, verify that it's up to spec. Again, if the human doesn't like something, it can comment, reassign the ticket back to the bot. In the next iteration, the bot will take that ticket. But ultimately, the human approves the pull request, merges the changes, and the task is over. And as we mentioned with Gun before, it's a collection of scripts and skills. It's just what it is. And I think one of the things that I wanted to highlight here as well that I'm kind of glossing over is that the agent gets access to move tasks on Jira, create tasks on Jira, gets access to open up a pull request, comment on pull request, fetch comments from the pull request. All of this is handled by CLI tools, not MCPs, just CLI tools that sometimes wrap other CLI tools. And I think it's important because wrapping a CLI tool with your own CLI tool, you can A, limit the blast radius of what the agent can do, and B, you can also automate certain parts. So for example, what is the next task the agent should work on? Well, there is a set of criteria that I've came up with that is implemented now in a script. It's a 5-step or 6-step process to determine which task is the next task to work on. The agent could use the Jira MCP and logic its way around it, but in my experience, it makes mistakes, and then it starts working on something that it shouldn't start working. So that's where adding CLI tools which have more deterministic nature is helpful. And for the maintenance, ultimately in this loop, any idea you have loops back to the beginning. So you start with a plan, you plan for the implementation, etc. The one thing that I wanted to put here in maintenance that I think works spectacularly well is the idea of a retrospective. I ask the agent every week, hey, review all the conversations we had in the past week, identify friction points, identify what works, see what doesn't, suggest improvements, and that is working really, really well. Has been working really, really well. Yeah, so that's basically it from my side. The bottleneck isn't code generation anymore. It's building out a process where code generation can run smoothly. And that's all for me. If there are any questions, I'm happy to share.